Morning, everybody. Welcome to Little's Lab. My name is Kim. I am a community learning specialist with DoSpace. And this month for our theme for Little's Lab, because every month we have a different theme and we do activities kind of that goes within that theme or little or that kind of an idea that we do a lot of different activities around is we have been doing experiments. So we have been learning about experiments and what is an experiment and who does experiments. So that's my first question for you is, what is an experiment? Do you know what an experiment is? I bet you know what an experiment is and that maybe you don't even know that you know what it is because you have probably been doing experiments your entire life because an experiment is just testing something. It's trying out something to find the answer to a question. So you might have experimented like, what happens if I put my hand on what looks like this water? Is it water? I don't know. Let's test it out. And then with your senses, you can figure out like, does that feel like water? Maybe it's not water. Maybe it's like honey because honey is sticky, right? So maybe, or does it look like, something? So, or maybe it's, what does this thing feel like? Maybe if you've never touched something before and you're like, what does that feel like? And you might see just with your eyes that like it might look hard, but it could be soft as well. And you have to kind of experiment by touching it and feeling it and finding out. And so there are so many different ways to do experiments. And so today we are going to be doing an experiment with some water. So I have like this little thing of water and we're going to be doing experiments to find out if things float or if they sink. And that's a really great beginner experiment, right? Because you might see something and you might think, well, that definitely sinks and it might float. And you might see something and that definitely floats. And it might float and you would be right. So we're going to be talking about that. So we're going to be talking about doing that experiment and how we are going to be making an hypothesis, which is like a guess. A hypothesis is a fancy word for science. And when you do a guess and you want to find out if your guess is correct. And then I asked you, who does experiments? Who are people that do experiments? A lot of times people might say like scientists do experiments, right? Because a lot of times we think about experiments as science. We do science experiments, but a lot more people than just like, scientists can do experiments. You can do experiments. And you know what that makes you? A scientist. So a lot of times people think, well, I have to go to school for a long, long time to become a scientist. That's not so. You can be a scientist today by doing an experiment. So you are going to be a scientist with me as we do some experiments with our water. And so, so we're going to talk about that a little bit more about our experiment here in a little bit. But before we get started, I want to have us check out our calendar today. I always like doing our calendar because it helps us with our numbers and our days of the week and even our letters, and that is so important, especially in science, right? When we're doing experiments, a lot of times we might work with numbers, so it's so important to know our numbers, right? And a calendar can help us with that. So let's do that. I'm going to share my screen with you really quickly, and we are gonna share, there we go. Have to get the right one, right? So so this is our calendar. It doesn't look like a calendar right now, but it will in just a moment. And this, I like this website. It's called Starfall. It's our Starfall calendar, and I like it because it's pretty interactive. When we do Little's Lab here at DoSpace, we have a room that's called Little's Lab, and in that room there's a big touch screen, like computer monitor, like probably something similar that you're watching me on, but it's touch screen. And I would ask my friends to come up and touch the screen, and it'll help move along our website. But even we can't do that because we're not able to do our program anymore in the building. But I want you to pretend with me. Can you pretend Do you know what that means? We're going to pretend that you are moving our calendar along, our website along. And we're going to do that by, you are going to actually touch different things on your screen, and that's going to move us along. So for example, you should see a big white triangle right here in the middle of your screen. Can you go ahead and touch that in 3, 2, 1, touch? Did your screen change? Nice. So you should be able to see now the month that we're in and the year that we're in. So this word right here is our month, and this big number is our year that we're in. So really quickly, I want to talk about this first word. This is the month that we're in. So my question for you is, who knows what our very first word, or sorry, our very first letter, what is this letter? Our very first letter in our word, that is our month. So do you know what this letter is? It makes the j. Oh, it makes the j sound. And if you said J, like I just said J, then you would be right. This is our letter J that makes the j sound. And then you might even know what our month is called. Do you know what our month is called that starts with our letter J? We have a lot of months that start with our letter J. Throughout our year, we have January, our very first month. Last month, we had June. And this month, we are in July. Our month is called July. So we are in July. And then this is our big number, right? Do you know all these numbers in our big number? What's this number? Is it 2020? Yes, that we are in the year 2020. It's a really big number. Perfect. Okay, so now I want you to touch this big green arrow in 3, 2, 1, go. Nice. So now it looks more like our calendar, right? So if you've ever looked at a paper calendar or email, usually they look like this with our dates and our day of the week. And then right up here, we have our month and our year, right? And like I said, we have our days of the week right underneath, and they are so important to know. It's so good to know our days of the week because we repeat our days of the week every month throughout all year long. So it's so important to know our days of the week. So let's say them all together. I want you to say them with the person you're with the people that you're with, and I'm going to say them with you. And let's start with Sunday. So there's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So those are our 7 days of the week. So who knows what today's day of the week is? You might not be seeing it on our today's day of the week. So your day of the week might be different than the day of the week that I am recording this on. But if we always record these on 2 days of the week, and one of them is this day. It's all Goldie, and it comes after Monday, but before Wednesday. And it is Tuesday. Today, our day of the week today is Tuesday. So how about you go ahead and touch that Tuesday right now? Go ahead and touch that Tuesday. Perfect. So today is Tuesday. That's our day of the week. Our month is called July. And then this number is our date today, and it has a big purple star on it. And so you can see these are all the Tuesdays in our month of July. And so, but today we're on this Tuesday. Who knows what this number is? It's kind of a big number, right? So when a 1 is in front of a 4, that makes the number 14. So today is the 14th day of July. Perfect. So we are going to touch this green arrow. Can you touch this green arrow for me one more time? Touch it right now. Excellent. And so we need to put our Tuesday and our 14 where they need to go. So can you touch and kind of drag and drop with me? So can you touch? Are you dragging it with your finger? Yeah, well, let's put it where it needs to go in our day of the week, our Tuesday. Nice. Let's do the same thing with our 14, our 14th day of July. Excellent. And we're going to touch this green arrow one more time right now. Perfect. So I like this calendar because it shows little pictures or icons on special days that we have going on in that month. And a lot of times they don't always, a lot of times they show special days that may not be celebrated all over in where I live in the United States. Sometimes they'll show days that are celebrated maybe primarily in other parts of the world, which I really like. So for example, our very first kind of fun day with that picture icon, you should see is our very first day of the month on Wednesday, July 1st. You should see a red maple leaf. This is a red maple leaf, and it is a red maple leaf because this day was Canada Day. And so Canada is the country that's straight north of the United States. So if you look at a map and you could find the United States, the country above the United States straight north is Canada. And that day is a day where they celebrate, where they have areas called provinces, kind of like how we have states in the United States, different areas called states. They have different areas called provinces. And Canada Day is when all these different provinces came together to become what we know as Canada. And so that is what Canada Day is. And so they celebrate that in Canada. And then our next kind of holiday is this day on the 4th. And I bet if you live in the United States, you probably celebrated this day, our Independence Day, or the 4th of July. Yeah, so that was our 4th of July day on July 4th. Kind of in the name, right? And you probably shot off some fireworks and maybe ate some yummy food. And so that is July 4th. And then our last one is on Friday, July 31st, on our very last day of the month. And it is called Eid Al-Adha. And so it is a holiday that is celebrated. It's an Islamic holiday that is celebrated in the Muslim community. So people, if you are Muslim, you might be celebrating Eid Al-Adha. So that is on Friday, July 31st. And I also like this because we can also talk about birthdays, right? Because I have a birthday and you have a birthday, but they may not be in our month of July. Like my birthday is not in July. And so I'm wondering, does anybody have a birthday in our month of July? Do you have a birthday in the month of July? What day of the month is, or day of the week is it? What date is it? And if you're joining us on Zoom, you can always share in the chat if you have a birthday in July. And if you don't, that's okay. Because like I said, not everybody has birthdays in our month of July. And so it doesn't look like it, but if you do, share with the people that you're with what day of the week your birthday is on. I'm going to put a little piece of cake on Friday, July 17th, because that is the birthday of somebody special to me, my daughter. She's going to be turning 1, which is pretty cool. So her birthday is on Friday, July 17th. Excellent. Okay, so I am going to stop sharing my screen, and I want to talk a little bit more about our experiments today. So we're going to be reading a story that's called Ada Twist Scientist. And so like I said, anybody really can be a scientist, right? And so a scientist is somebody a lot of times that does experiments or trying to figure out the answer to a question or something people might not know. A lot of times people do experiments to find out something that maybe nobody else has found the answer to. And they are trying to do that. They are trying to find that answer. They're trying to find a solution to a problem. A lot of times you can do experiments to find a solution to a problem as well. So that's really important. So we are going to be doing reading a story called Ada Twist Scientist. And she is going to be trying to figure out the solution to a problem she has by doing experiments. And she'll also have what are called hypotheses. And a hypothesis is a guess. So if you might say, like, you might have a problem, like maybe you might think, this cake tastes funny. Maybe you've tried a piece of cake and you think, this cake tastes funny. I wonder why this cake tastes funny. And you might think, well, maybe whoever baked it has put too much salt in it. And somebody else might say, well, maybe they put too much sugar in it. And maybe somebody else says, well, maybe the baker put too much flour in it. And so those are all guesses, right, of why of why the cake tastes funny. And so those are all hypotheses. And so a scientist might go back and be like, Baker, how did you bake your cake? And they might be able to look at the ingredients and bake the cake based off those ingredients. And you might be able to see, ooh, maybe this person put too much salt, or maybe they put too much sugar, or maybe they put too much flour. And that's just an example of how hypotheses work. They're guesses. And so she's going to be making guesses to why, how to solve her problem. So I'm going to share with you my screen one more time so that we can read Ada Twist, Scientist. I hope you can see this. So Ada Twist, Scientist by Andrea Beatty, illustrated by David Roberts. I think her books are so great. So let's read Ada Twist, Scientist. Ada Marie said not a word until she turned 3. She bounced in her crib and looked all around, observing the world, but not making a sound. She learned how to climb and made her big break with a trail of chaos left in her wake. And she ran through the day chasing each sound and sight and didn't slow down till she conked out at night. You know what conked out means? It means she just fell right asleep. Looks like she conked out, fell right asleep on her dresser. Her parents were frazzled, but tried not to freak as Ada grew bigger and still did not speak. Clearly young Ada, with lots in her head, would have something to say when it ought to be said. So it looks like she's doing a lot of observations, right? Or looking and thinking about what she's seeing, but she's not saying much. That's just what happened when Ada turned 3. She tore through the house on a fact-finding spree and climbed up the clock just as high as she could. And her parents yelled, "Stop!" as all good parents would, right? Because look at that. She's all the way up at that clock. Woo, and it's so high and she fell. She might hurt herself. So Ada quivered, but she did not cry. She took a deep breath and simply asked, "Why?" Have you ever asked your grown-up why? I bet you have. Because you want to know. Why is the question you ask when you want to know something. Why? Why did something work like that? And why are they telling her to stop? Why does it tick and why does it talk? I think she's referring to this clock. Why don't we call it a granddaughter clock? Why are there pointy things stuck to a rose? And why are there hairs up inside your nose? She started with why, and then what, how, and when. By bedtime, she came back to why once again. She drifted to sleep as her dazed parents smiled at the curious thoughts of their curious child who wanted to know what the world was about. They kissed her and whispered, "You'll figure it out." So all of these questions, why, what, how, when, those are such good questions for a scientist because those questions help you learn about the world. Her parents kept up with their high-flying kid whose questions and chaos both grew as she did. Ooh, look at all these questions. She's why, what now? What does it do? What is it for? Will it be the same? What if? Oh, how can I find it? What does it? How? All of these different questions she is asking her parents. And even Miss Greer found her hands were quite full when young Ada's chaos wreaked havoc at school. But this much was clear about Miss Ada Twist. She had all the traits of a great scientist. She's asking all these questions, right? And Ada was busy for the first day of spring, testing the sounds that make mockingbirds sing, when a horrible stench whacked her right in the nose, a pungent aroma that curled up her toes. Pungent means it's really strong and a lot of times really stinky. A lot of times when something is pungent, it's something that's a really strong smell. And a lot of times it's like, P.U., no thank you. And zowie, said Ada, which got her to thinking. What is the source of that terrible stinking? How does a nose know there's something to smell? And does it still stink if there's no nose to tell? She rattled off questions and tapped on her chin. She'd start at the start where she ought to begin. A mystery, a riddle, a puzzle, a quest. That was the moment that Ada loved best. Okay, friends, so she has a question. What is the source of this terrible smell that she's smelling? So she's going to be doing experiments to solve the question or answer the question. What is the source? What is making this terrible smell? Let's find out what she does to figure this out. Ada did research to learn all she could of smelling and smells, both stinky and good. One hypothesis Ada thought could be true. The terrible stink came from Dad's cabbage stew. She tested and tested, but soon Ada knew it was time to come up with hypothesis 2. Do you remember what a hypothesis was? It was a guess, right? So her guess was that the smell was coming from a really stinky stew made of cabbage that her dad was making. And she did experiments and she tested and she found out, nope, that was not the source. That's not where the stinky smell was coming from. So she was going to make another hypothesis, another guess. So let's see what her guess or hypothesis number 2 is. Then, zowie! The stink struck again, just like that. Hypothesis 2. It's caused by the cat. So she thinks the cat might be so stinky. That's her second guess, her second hypothesis. The cat couldn't make such a stink on its own. It needed perfume and some fancy cologne. So young Ada tested. The test was a flop. She started again, but her parents yelled, "Stop!" Why did her parents yell stop? What is she trying to do? Is she trying to wash her kitty cat in the washing machine? That's not good for kitty cats, right? So, yeah, sometimes when you test something, sometimes you do experiments, and they don't always work. And that's okay. That's part of science. Because a lot of times if you find out what doesn't work, that helps you find out what does work. And her parents yelled, Ada Marie, to the thinking chair now. By the time we count 3. Enough, said her mother. That's it, said her dad. Her parents were frustrated, frazzled, and mad. Why? Ada questioned. Her mother said no. What? Ada queried, and her father said, go. You've ruined our supper, and you've made the cat stink. Enough with your questions. Now sit there and think. She looked at her parents, and her heart turned to goo. Poor Ada Twist didn't know what to do. Sometimes it's hard to do experiments, right? Especially for our grown-ups. When you're trying to figure things out, sometimes it can be a little hard. So she had to go do some thinking. She sat all alone by herself in the hall, and Ada once more could say nothing at all. And so Ada sat, and she sat, and she thought about science and Stu and the cat, and how her experiments made such a great mess. Does it have to be so? Is that part of success? Are messes a problem? And while she was thinking, what was the source of that terrible stinking? And Ada Marie did what scientists do. She asked a small question, and then she asked 2. And each of those led her to 3 questions more, and some of those questions resulted in 4. As Ada got thinking, she really dug in and scribbled her questions and tapped on her chin. And she started at why, and then when, how, and or where, what, how, and when. And at the end of the hall, she reached why once again. What is she doing? She's kind of drawing out her problems, right? She's trying to figure out the pictures, all of these questions. And her parents calmed down, and they came back to talk, and they looked at the hallway and just had to gawk. No patch of bare paint could be seen on the wall. The thinking chair now was the great thinking hall, and they watched their young daughter and sighed as they did. What would they do with this curious kid, and who wanted to know what the world was about? And they smiled and whispered, and we'll figure it out, right? Because they knew they didn't want to make her feel sad about asking questions, because it's important, right? It's important to ask questions and figure out about the world. And so her parents were going to figure it out. And that's what they did, because that's what you do when your kid has a passion, a heart that is true. They remade their world, and now they're all in the act of helping young Ada sort fiction from fact. And she asked lots of questions. How could she resist? It's all in the heart of a young scientist. So now, instead of maybe being mad at her problems, they're going to help her out. They're going to help her figure out what the solution to the problem is. And as for that smell, what can Ada Twist do but learn all she can with her friends in grade 2? And will they discover the stink that curls toes? Well, that is the question. And someday, who knows? So, did they quite figure out what the cause of that great stink was? Not quite. But it looks like with the help of her class, they are going to do some experiments and maybe figure it out someday. Not today, but someday. Ugh, I love Ada Twist Scientist. I think it's such a great story. Okay, friends, I think we're ready to do experiments for ourselves. Let's do that. I am going to stop sharing so that you can see me all really good, and we are going to do our own experiments. So today, like I said at the very beginning of class, we are going to do experiments. We are going to see what floats and what sinks. So maybe you want to keep track. You might keep track and have a column if you want. You could take a piece of paper and have a column, and one column says sinks and one column says floats, and you can write down what we're testing and keep track and kind of maybe put a check mark or an X side in the columns that say sink or float. And so the cool thing about this is that you could do this experiment at home as well. I just grabbed some things that I found around the building, but you could do this experiment super easy at home as well, after class, with things that you have around your house to figure out what sinks and what floats. So let's get started. I have a few things. First thing we have is I have this square, or this cube, it's actually a cube, piece of foam. So we are going to find out, and I'm going to add a little bit more water so it's easier to get out. So now I have a little bit more water, and we are going to find out. So I want you to make a hypothesis with the people that you're with. I want you to guess. So your hypothesis is either that this will float, or your hypothesis is it will sink. And if you're right, that's so good. But if you're not, that's okay. You're learning, right? If you decide that it floats and it doesn't float, then that's okay, because then you're learning that it does, and that helps you for the future. So let's find out. Let's make our hypothesis. You tell the people that you're with, will this sink or will this float? And we'll find out in 3, 2, 1. Oh, it floats. How many of you said it was going to float? Our cube is floating. So we know that our cube is lighter than the water. So it is a floater. Okay, let's try something else. I have this metal bolt here, or metal nut. It's a piece of metal that you can like screw onto screws, right? So my next question for you is, does this sink or does it float? Put in your hypothesis. What do you think? Let's find out. 1, 2, 3. Oh my goodness, that sunk right to the bottom, right? I don't think I'm gonna get it out. If it sunk, it sunk. So that sunk right to the bottom. No floating at all. It was heavy. Okay, how many of you said this was gonna sink? How many of you just said it was gonna float? Okay, next thing. I have a crayon. I bet you have some crayons at home. This one's, I think, gonna be tricky. Who thinks this is gonna sink? Who thinks it's gonna float? Let's find out. 3, 2, 1. Oh, it kind of is hard to tell. I think it sunk. It's taller than our water, but it's not. You can tell that it's touching the very, very bottom. So it's definitely not floating. So if it was floating, it wouldn't be. It goes right. You can see how that goes right to the bottom when I bring it up. it just sinks right to the bottom. So it does not float, it sinks. Even though it's higher, it's taller than the water that we're in. Okay, what else do I have? I have a paper clip. I have this paper clip. Who thinks this is gonna sink? Who thinks it's gonna float? Let's find out. It is going to, oh, it sunk. Can you see that in there? Our paper clip sunk. It did not float. How many of you said that? Okay, let's do a few more things. I have this kind of plasticky ball. Let's see, who thinks this ball is going to sink? Who thinks it's going to float? Let's find out. Oh, it floats. Our ball floats. So it has air enough in it so it allows it to float. So it is a floating ball. Perfect. Okay, a few more things. They're kind of small, these little things that I have. So 2 more, and then we'll finish up our Littles Lab. Okay. Okay, we need a few more hypotheses. I have a little pony bead. The little guy, little pony bead. Who thinks it's going to sink? Who's going to hypothesize it's going to sink? Who's going to hypothesize that it's going to float? Share with the people that you're with, and let's find out in 3, 2, 1. Oh, it floated. I'm not going to lie. In my head, I hypothesized that it was going to sink. I thought this was going to straight up sink, but it floated. So I learned something. I'm not going to dig it out because my hand can't fit. So one last thing, okay? We got one last thing before we need to finish up Little's Lab. It's kind of small. It's a little puff ball. I should have found some things that were a little bit bigger. Oops. But I have this tiny little puff ball. Who thinks this is going to sink? Who thinks it's going to float? Let's find out. In 3, 2, 1. There we go. Did our bead sink? Wasn't it just floating? It was just floating. So it looks like some things will float initially and then they'll sink. So, but our little puff ball, you can see it's kind of floating right there at the top, not at the very, and then you can see our pony bead that was just floating has sunk. Or did we say it, or did it always sink? No, it was floating. That's funny. Sometimes science is funny. It's a little bit fickle. So yeah, so try that out at home. Test some things. What are some things you have around the house that you can test? Sinks or floats? Make some hypotheses and maybe try out some different experiments this week and be a scientist. So yeah, well, excellent. You guys, thank you so much for joining me for Little's Lab. I super appreciate it. I hope you had fun. And we will see you next time for some more experiments. We're going to be doing some experiments with balloons next week. So join us next week for some experiments with balloons. Have a good rest of your day. Bye.